we will be able to share a Google link form for attendance, because it's this attendance where we will once again capture whether you have been able to attend the class for the 3 days, whether you qualify to get the assessment so that you can access your certificate. So be attentive. At the end of it, we request all of you to become ambassadors of this digital skilling program from the ICT Authority. Reaching out to Kenyans, we are reaching out to all citizens. Become our good ambassadors, market this program, tell all citizens to go to the Smart Academy portal and access courses which the ICT Authority is offering. We'll be able to take more questions at the end of the day's training. I'll be here with you. I know there are colleagues who are here. And Ricky, if possible, you can check whether we have Lynette Rigera and you can bring her as a participant, as a presenter to officially open this training for us. Then we get started. Otherwise, if it might take you long, we'll just get started because time is moving and most of our trainees have been able to join. Ricky, over to you. If you can check for that name and make a presenter.
Thank you, Connie. I hope I'm audible enough.
Yes, you are.
Thank you, Connie, again. As I said, my name is Ricky, as you've mentioned, Ricky Omondi from Sigma Digital and Technical Institute. I am the head of business development and partnership. And I would like to warmly welcome you all to our data analytics training program, delivered in partnership with the ICT Authority under the Training 20 Million Citizen Initiative. We are delighted to have you with us over the next 3 days. And I believe you'll gain practical skills in data analytics, visualization, Microsoft Excel, Power BI, data-driven decision-making. And we encourage you to actively participate, just as Connie has said, ask questions, and make the most of this opportunity. It is now my pleasure to introduce our facilitator for the day, Ms. Wangare Muchai. Ms. Wangare is a data scientist, AI specialist, and a certified trainer at TOT with a master's degrees in data science and analytics from the University of Nairobi. She has extensive experience training professionals in data analytics, artificial intelligence, business intelligence, Power BI, Python, data visualization, and is also well known for making complex concepts practical and easy to understand. So again, I welcome you all. Let's get ready for this exciting class as we look forward to having everyone engaged in this session. Karibu sana, Ms. Wangare Muchai, take the floor.
Thank you so much, Ricky. Good evening, all. I hope you all had a wonderful day. Welcome to our training on data analytics. I'm hoping it's going to be a wonderful session. In case you have a question, we have a Q&A slot. Just write in your questions there. Then there'll be someone who will take care of them as we continue. So in case, kindly, because we are so many, we might not be able to give you a chance to speak. So that is why we are asking you to just write your questions. Now, I am not so sure how many of you have interacted with data analytics or something to do with data, but I hope you've had something to do with data which is not data bundles, yeah? We're talking data information, yeah? So that is what we are supposed to look at today. And we're going to look at foundations of data analytics, and if time allows, we're also going to cover Microsoft Excel for data analytics. I'm so sure a number of us have come across, or rather have used Microsoft Excel or Excel in maybe data storage, in case you have an Excel file or a CSV file, something of the sort, or for people who are in the, maybe in the, accounting or in auditing, they usually use Excel most times for their analysis. So that is what we're going to look at as well. So by the end of this session, you're supposed to be able to explain the difference between data, information, and insights. We're also going to look at business intelligence, analytics, data science, machine learning, and artificial intelligence. After that, we're going to look at data collection and data quality, and look at the different ways of collecting data, and also assess data quality using how we assess data quality using key dimensions. Then you're going to look at different tools that are used in data analytics or for data analytics. And now that is where we're going to transition to Microsoft Excel as one of the data analytics tool. So that is what we're supposed to cover today. And I'm hoping it's going to be an easy session, yeah? So we first start by defining what data is. And even before I proceed, maybe Ricky or Malcolm, you can help me in case you get an answer on the chat box. You can just pick it out. I just want to know how many of you have interacted with data before, and according to you, what is data? How do you understand data? Yeah, how do you understand data? Ricky, if there are any, there are any responses on the chat, maybe you can read them out for me. Yeah. What is data according to you? Or if I mention data, what comes to your mind?
Hungary, we are having some responses coming in.
Yes.
We have anonymous users saying these are raw facts and figures.
Yeah.
We have another user saying data is raw or unprocessed information. I think we still have, actually that is majority of the responses we're getting. Data is raw facts, data is information, facts, information. That is basically what majority of the class is saying.
Okay, thank you so much. Thank you. So from what has been read out, most of you are saying data is basically raw facts and figures, unprocessed information, or facts and figures, yeah? So that is what data is. And data refers to raw facts, figures, observations, or measurements collected. Okay, so we have facts, figures, observation, and measurements. It could be, that is to mean, if we have facts, it really doesn't have to be numbers, yeah, or figures. It could be text type of data. There are those times you collect data through observations, yeah, like behavioral type of data, or measurements collected about people, events, or processes before they have been processed or interpreted. In short, data is unprocessed information, as raw as it is, yeah? If you're talking about behavioral type of data, when you observe something, even before interpreting what it means, that is what data is. That is behavioral data, okay? So on its own, data has very little meaning. What does that mean? Remember, it's unprocessed. So you might not really understand what these figures are until you process that information. And that is where data analytics comes in. So examples of data, we have student examination scores. That is just a table containing information about scores for students. Yeah, hospital patient records, we have monthly government expenditure, M-Pesa transactions, employee attendance records, and also tax collections. Those are just some of the types of data, or not types, but examples of data. So for example, what we have here, we have a table of employees, the county they are working from, and the salary they earn. So we have John, Nairobi, 75,000, Mary, Kiambu, 68,000, Peter from Nakuru County, and he earns 82,000. So you might not be able to get information per se from this table because these are just records. Yeah. So in short, data is just unprocessed records of either facts or figures or observations. Okay. Now, where does data, before we proceed to data analytics, we have characteristics of data. One, data is structured. That is to mean it is either in form of numbers, financial transactions, or when you, in cases where you have locational type of data, we have GPS coordinates. Your data can be text type of data, where you have reports, records, citizen complaints. For example, the data that we have here is a combination of figures and texts. Yeah, so that is text type of data. Then we have multimedia, that is maybe something like images, audio recordings, and video. Then we have sensor data. This is these are readings from IoT, Internet of Things devices, and environmental monitors. So organizations collect both structured and unstructured data from multiple sources. Yeah. Now, how do we come from data to information? Okay, so and that is basically what data analytics is. Remember, we've said data is raw information. It has not been processed. We have not gotten any insight from that data or from those records. Yeah, so we need to come from data to information for us to be able to use this data or to make this data meaningful. Yeah, so for example, we have raw data here, a list of numbers, 68, 74, 81, 90, and 62. We don't know what that is. It could be, a list of scores, yeah? But now, for us to make use, or rather for us to get information from the raw data, how do we go about that? Okay, so between raw data and information, we have a process that is called data analysis. So, and what happens during data analysis? So that is where we organize and clean data. So we want to sort this data, we want to validate, and you want to remove errors. Yeah. Why? Because before you want to make sure that the information that you get is as accurate as it should be. So you have to make sure that your data is clean enough. And what are we cleaning from data? One, we could have repeated records, duplicates. So we want to do away with those duplicates. Number two, in those cases where we have missing values, how do we deal with those missing values? We can decide to do away with the missing values, or we can decide to replace the missing values. Yeah. In cases where we have structural errors, yeah, something like maybe the names are written in, they are mixed up. We have We have capital letters and small letters. How do we go about that? So we need to make sure that our data is clean enough. So we need to organize and clean that data. Then we go ahead and contextualize. This is where we combine data with meaning and purpose. Okay? So after that, after we do that, after cleaning that data and contextualizing it, we get information. So, unlike raw data, information is processed and organized data that has meaning and context, which helps us understand what the data is telling us. So that is to mean, once we've collected data, we don't stop at that point. We go ahead and do what? And clean that data so that we are able to get more information, or we are able now to get meaning and context from your data. Yeah, I hope that is clear, and I hope you're able to differentiate between data and information. Now, what are insights? Insights are meaningful conclusions. In other words, insights are conclusions. So we are coming from data. We have cleaned that data and organized that data to get information. So the conclusion we get from this information is what we call insights. Okay? So insights are meaningful conclusions drawn from analyzing information, and they answer important business or organizational questions, and which guide decision making. By the way, before I proceed, I know we are going to come across that, but I need to mention that the main reason why we do data analysis, we are trying to convert data to decisions. Decisions are the end goal. That is where, I mean, whenever you're given data, you want to see how you can make decisions from that data. And what is the process? The process is raw information, that is data. We clean that data to get information. From that information, we analyze that information to get meaningful conclusions. And these meaningful conclusions are going to help us make decisions. Okay, so for example, the information that we have here is that the average score is 75%. What is the insight? The insight here is, or what conclusion can we get from this information? That students with attendance above 90% consistently scored above 80%. Then what decision do we make? The decision is, if we increase attendance monitoring, so the decision is we're supposed to increase attendance monitoring and student engagement programs. Okay, so I want you to realize we are coming from raw data to making, to getting information from the raw data. Then we get insights by analyzing that information. Then from there, we are able to make decisions. Okay, so these are the differences. So data, we have raw facts. Information, it is processed data. Then insights are actionable conclusions. From, I mean, when you have data, there's little meaning. That is to mean you're not able to gather a lot of, information from your data as raw as it is. When it comes to information, now it gives you some context. Then from the insights, it helps you because, insights are meaningful conclusions, so it helps to support decisions. For data, data can be individual records. Information is basically summaries and reports. Then insights are recommendations. Yeah, and you have practical examples here. Like for data, we have hospital records where we have each patient's waiting time, then information average waiting time in is 2 hours. So that is to mean we've gotten this information from this data. Yeah, so we have patient 1, they waited for 2 hours. Patient 2 waited for 3 hours. Patient 4 waited for 1 hour. So when they do the average, we get the information, and the information is the average waiting time is 2 hours. So from that information, what conclusion can we, what conclusion can we draw? The conclusion is delays peak hours, or rather delays peak is between 10 a.m. and 1 p.m. due to understaffing. So that is the conclusion we've drawn. Now, with that conclusion, what decision are you going to make? The decision is, or rather the decision will be, you're supposed to deploy additional clinicians during peak hours. Like between 10 a.m. and 1 p.m., you're supposed to have maybe 5 clinicians instead of 2. Okay, so that is how we make use of data to help us make decisions. Yeah, now, for our case, why is data important? Right now, everyone is talking about data, artificial intelligence. So why is it important? And I believe most of us are in the public sector, and there are those that are in the private sector. So data is important because it helps in policy formulation. You cannot come up with policies without data. Why? Because you need evidence to support those policies, okay? Or rather evidence to, because you're effecting something, yeah? So that is to mean, because it's a decision that we are trying to make, then we have to have, it has to be an evidence-based decision. Number 2, when it comes to budget allocation, you need to have data of, in this department, these are our expenses this year, and we need this amount of money, blah, 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 and so on and so forth. When it comes to monitoring and evaluation, you also need data. And when it comes to disaster preparedness, you also need data. So for our case, we have KNBS, Kenya National Bureau of Statistics, which collects census data every 10 years to guide distribution of schools, hospitals, roads, and water projects across counties. And without reliable data, governments risks decisions based on assumptions. Okay? So with data, you're able to make evidence-based decisions rather than decisions made from assumptions. Okay, I hope that is clear. Now, remember we've said the end goal of data analytics is decision making. Yeah, so what is the workflow of data to decision? 1, we have business problem. What are we trying to solve? You need to understand the problem that you're trying to solve. Either it has already been defined, or you want to find out what problem are we trying to solve here. So you need to understand your problem. Once you understand your problem, you'll be able to know the type of data you're supposed to collect. Okay? That is to mean you want to collect relevant data, or data that is relevant to your business problem. Once you collect data, remember we said you need to clean and organize your data. Okay? So we start by cleaning data. What are we cleaning? Again, this is very this is very common, not common, but it's something that you're going to come across it in all the data analytics tools. We clean. The reason why we clean data, we want to remove duplicates. That is the first thing, to avoid redundancy. Number 2, we want to handle missing values. In those cases where you have missing values could be because of maybe while collecting data, you didn't collect it. I mean, you weren't able to record some information and so on and so forth. Yeah. So you need to remove those ones. You either remove missing values or you replace them. Okay. Sometimes we have structural errors. We also need to sort them out. So those are some of the, some of the things or some of the errors that you're trying to handle at the data cleaning level. Once we are done with data cleaning, we go to data preparation. So why are we preparing this data? We are preparing the data for analysis. Yeah, so under data preparation, that is where we have feature engineering. You want to make sure that your data is fit or ready for analysis. Sometimes you have text type of data, but you need to convert it to, or you need to change it to some other format that would that is allowed for data analysis. So that is where we have data preparation. So once you've prepared your data for analysis, you can now proceed to your analysis. Then from the results, you will be able to do what? To draw conclusions or get some insights. Then with the insights, you will be able to make decisions. Okay, I hope that is clear. So that is the data to decision journey. So we can now proceed. Now we've understood what data is, what information is, what insights are, and what decisions are. Okay, now let us now proceed to data analytics. So data analytics is a combination of all those things, yeah, from data to decisions. So data analytics is the science and practice of using data to answer questions, solve problems, and improve performance and support informed decision making. And what does it entail? It entails collecting data. Data has to be there. You collect the data, clean that data, transform that data, analyze and interpret. Okay, interpreting, in the process of interpreting, that is where we get the insights. To discover meaningful patterns, identify trends, and support evidence-based decisions. Okay, again, we start by collecting data. It is the process of collecting data, cleaning that data, transforming it, analyzing, and interpreting data. Now, as we are doing all this, remember the first step was to understand your business problem. Once you understand your business problem, you will be able to know which data am I collecting. You collect that data. After that, you clean and transform that data. Then you will also, with the, with you understanding what your business problem is, you'll be able to know what type of analysis am I supposed to perform. Okay. Then after that, the results that you get, you're supposed to interpret those results. And with those results, you're going to come across meaningful patterns. Those results could be in form of meaningful patterns or trends. And these trends and patterns are supposed to help you make decisions, evidence-based decisions. And what is the evidence in this case? The evidence is your data. Okay? I hope that is clear. Data analytics, you need to first understand your business problem. What am I solving? Then after that, you'll be able to know the type of data to collect. Then you now go to the cleaning and transformation of that data. With the, with you having understood what what problem you're trying to solve, you'll be able to know what type of analysis am I supposed to perform, okay? Then you go ahead and interpret your data or your results to help you make evidence-based decisions. So why do organizations need data analytics? So every organization generates enormous amounts of data daily, and without analysis, this data simply accumulates without creating value. So we need to make use of this data that is generated. When it comes to finance, in the finance and accounting department, we have financial records, which could be in form of transactions, payroll, or procurement. Yeah. When it comes to health records, we have patient data, diagnosis, and also births. How many children have been born in this period of time or between this period of time? And then you try and see how will that information help us. Then when it comes to citizen data, we have complaints, we have service requests, we have census. And for educational type of data, we have examination results and attendance. Yeah. And of course, with the examination results, you're able to be graded. Yeah. So data analytics converts raw information into knowledge that improves decision making. Yeah. So what you're supposed to know is, with the information that I have, how am I going to use that information? Okay. Now we have practical examples here. I'm sure there are some health workers here or people who work in the health department. So we have data that is usually collected daily, data like patients treated and diseases diagnosed. We have medicine dispensed. We have number of births and maternal deaths. And we also have something like waiting time before treatment. So you want to know, or rather you want to make use of this data that has been collected. And we have questions analytics can answer based on the this data that has been collected. Yeah. For example, for example, the first type of data or the first data set that was collected was patients treated and diseases diagnosed. So if malaria was one of the diseases, so you want to know which counties have the highest malaria cases. Okay, so you can answer that question with the first data set. Number two, which hospitals face medicine shortages? Which facilities need more healthcare workers? Which diseases are increasing over time? Okay, so these are some of the things that, these are some of the questions that can be answered using data that has been collected. So using these insights, the Ministry of Health can allocate resources where they are needed most. That is the first example. I hope this is something that is making sense, yeah, and it's something that you can relate to for those that are in the health department. For those that are, maybe they work at Kenya Revenue Authority or in the county government. So KRA processes millions of tax transactions annually. So through analytics, KRA can identify tax compliance trends. That is the first thing, based on the taxes that were filed in 2025, 2024, 2023, and so on and so forth. They can use that information to identify tax compliance trends. Then if they want to detect fraudulent tax returns, they can also use the data that they usually collect. If they want to predict future tax revenue, they're going to use historical data, data that has been collected before, in the previous years, just to, it might not be as like 100% accurate, but it can give them an idea of taxes to, to expect, or tax revenue to expect in the following year. Then we have, if they want to prioritize high-risk audit cases, they're going to use historical data and observe the trends. Then they'll be able to tell what is going on and even go ahead and make decisions. That is KRA. So in county government, analyzing thousands of complaints from a customer service portal reveals, for example, 45% relate to water shortages. Most complaints are from 3 words. Complaints spike during dry seasons. And with this information, the county can prioritize water infrastructure in those words. So you realize after every analysis, or rather, once we analyze data, we want to make decisions. Yeah, the goal is, what decision can we make based on this data? So we have evidence. We want to make use of that evidence to make a decision. Yeah, so from these complaints, the county government will be able to know where to prioritize water infrastructure in their county, which words need most, which words need most of the help when it comes to water infrastructure. Okay, now what are the benefits of data analytics? Why are we collecting data, analyzing that data, and trying to use that data to make decisions? The key benefits of data analytics are: 1, it helps in better decision making. Why? Because this time you're making decisions based on evidence. You're not making decisions based on assumptions or I feel like. No, it's not about I feel like. It's about, this is the information that we've gathered and we need to use that information. We're going to use that information to make decisions. So it helps in better. Here, it helps in improving service delivery. So Huduma centers analyze waiting times to allocate staff during peak periods. So that is to mean it doesn't matter
Hello, Angari. Don't know whether it's from my end. I've lost your voice.
Yes, Connie, I also, let's find out what's happening,
Okay.
and then we get back. Just a
Okay,
minute.
to the trainees, kindly be patient. This is a technology issue as we try to get back the presenter and the trainer of the day. A moment, please.
Good evening, team. As we wait for Wangari to come, please note we are taking up all your questions on the chat. I've noted quite a few. Yes, so keep posting the questions. We have quite a number so far. I think about 50 to 60 questions, mostly talking about nodes. Some are talking about data. And please note the session is being recorded. And we are also live on YouTube. The link is on the chat I've placed under Malcolm. And I believe Wangari is now back. So just keep the information coming, keep the questions coming. We'll be able to address them during the Q&A session. Thank you.
Sorry about that. Let's see. So we were talking about key benefits of data analytics. And the first benefit is it helps us make better decisions. Number two, when it comes to service delivery, for example, the example that we have here where Huduma centers are trying to analyze waiting times to see how they can allocate staff during peak periods. It's going to help improve service delivery. Number three, efficient resource allocation. So for example, the Ministry of Health uses disease data to distribute vaccines where needed most. Number four, fraud detection. If missed, data flags duplicate payments and suspicious procurement transactions. And then when it comes to risk management, when you're talking about the Kenya Meteorological Department, when they're able to predict floods and issues early warnings, when they're able to predict floods in good time, they will help in disaster management. So those are the different places where we can apply data analytics. And of course, as I had mentioned, data analytics should make things work better because now you have evidence. So you're using that evidence to make things work better. So when it comes to policy formulation, one of the most important uses of data analytics in government is evidence-based policy development, and I had mentioned that. So policies should be grounded in data, not assumptions. Because if we use assumptions, for example, if you're coming up with a policy in the health department, remember, this policy is supposed to be effected in all the 47 counties. So we cannot assume that the situation in Wajir County is the same situation in Mombasa and it's the same situation in Nyandarua County. No, and that is why it is important when it comes to policies and policy development, make sure you use data because that is the truth of the matter, or rather, even though vitu ziko kwa ground. So instead of using assumptions or how you feel as a maybe as a CEC, kindly just use data, then you're going to make the right decisions. So before, for example, here, before introducing a youth employment program, the government analyzes unemployment data by county, age group, education level, gender and economic sector, ensuring interventions target populations with the greatest need. Okay, when it comes to allocation of funds, the same thing. They have to analyze based on a number of factors. Then they can now distribute those funds based on those factors or based on that data that has been collected. So data analytics help in developing evidence-based policies. Okay, So we have an activity here, and this is something that maybe I'm going to share these materials. Maybe you can think around it, considering that most of us are, in the public sector, and whichever department that you work in your organization, then maybe you can see what type of data that you guys collect, why is that data collected, how relevant is that data, and who uses that data, and from that data, what decisions are you able to make? Okay, so we were talking about data analytics and the key benefits. Now, what is the life cycle of data analytics? So for data analytics, as I had mentioned earlier, you have to understand the business problem. That is very key. By the way, you cannot proceed with analysis without understanding, why am I doing this analysis? What problem, what question am I trying to answer? So I still insist on that, because for those cases where you have not been given data before doing the analysis, and you have to start it from scratch, you have to know how you define those problems or the business questions. And from the business questions, are you able to get the right information or the right data? Okay. So under business problem, this is where you define the analytics questions. What are we trying to answer here? Then number 2, we go to data collection. I mean, data analytics cannot happen without data. Data has to be there. So we need to collect that data. So this is where you gather relevant data. Again, I insist on relevant data. And how are you going to collect relevant data? It's by only understanding the analytics questions. Okay, so you gather relevant data. Then once you collect that data or gather that data, the next thing is clean that data. So that is where you remove errors and inconsistencies. Then after that, you can now proceed to data analysis. Under data analysis, this is where you explore and model the data to be able to get insights. Then from the insights, you can do what? You can make decisions. That is the data analytics workflow. So remember, the first step is identifying, or rather defining, the business problem. So every project begins with a question. For example, why is county revenue declining? So we have a why there. So with that why, we are supposed to know, what type of data am I supposed to collect? Why is county revenue declining? Number 2, which regions have the highest dropout rates? Those are some of the examples of business questions. Then when it comes to data collection, we have different ways of collecting data. We can use surveys. We can use, we have systems that can be, human resource systems. We have IFMIS, we have eCitizen, we have KRA databases, we have census reports, and we have administrative records. So under data collection or data sources, we have 2 types of data sources. We have primary sources and secondary sources. So primary sources, you're the one going to collect the data as raw as it is. So you can collect that data in form of, using surveys and questionnaires and so on and so forth. Then you have secondary data that has already been collected. So someone shares a CSV file with you, that is a primary source. Okay. Once you collect your data, you go to data cleaning. Again, what are you doing in data cleaning? You want to remove duplicates. Why are you removing duplicates? To avoid redundancy. Why? Because that is repeated information. By the way, even before we proceed to data cleaning, because there's that subtopic, the only solution to duplicates or handling duplicates is removing them. You do not replace, you remove, because that is a repeated record. So we do not need it. We cannot change anything. Yeah, so we remove duplicates. You also want to correct errors. You also want to fill missing values. That is to mean handle missing values and also standardize formats. After that, you go to data preparation. This is where you sort your data, maybe in a certain order. You filter that data, create variables, categorize, combine data sets, and validate for analysis. Again, when it comes to data preparation, you need to know what kind of analysis am I doing for you to be able to know how should I prepare this data. You see, I'm going to give an example of if you are supposed to prepare kuku kienyeji this evening, you need to know the ingredients that you're going to use. Yeah, so you need to have chicken. That is the first thing. Number two, you need to have onions, you need to have tomatoes, you need to have those spices. So preparing, that kuku kienyeji is basically the analysis itself. And then data preparation is how we prepare the ingredients to help us come up, or rather to help us make this dish delicious. Okay, so that is data preparation. So that is to mean before data preparation, you need to know the analysis that you're doing. You do not prepare data without knowing the kind of analysis you're doing. Okay. Then we have now, so we've prepared this data, then we proceed to data analysis. You can apply descriptive statistics where you just want to understand how is your data, the general understanding of your data, descriptive statistics. That is where we usually have mean or average, median, mode, maximum, minimum. You want to understand the range of numbers. You want to understand standard deviation, and so on and so forth. Yani, summary statistics. Okay, that is descriptive statistics, sorry. Then we have summary statistics is where we have mean, median, mode. Descriptive statistics, you want to understand your data, and most times descriptive statistics is usually in form of visualizations. Yeah, visualizations, that is descriptive. Then we have trend analysis. Trend analysis, you want to understand what has been the performance over a period of time. For trend analysis, time has to be there. When it comes to correlation, you want to understand what is the relationship between factor 1 and factor 2. What is the relationship? Okay. Then we have pivot tables. Pivot tables are used for summary statistics. Okay, and pivot tables are mostly used in when you're using Microsoft Excel. Then we have forecasting. Forecasting is basically predicting. So you want to predict to answer the business question. So we have a number of analyses. And for you to decide on the analysis to work with, you need to understand the business question. What are we trying to answer? Okay. Then we have data visualization. Data visualizations, and we're going to look at that tomorrow, is basically illustrating your data in charts and graphs. It's graphical illustration of your data. Graphical illustration of your data makes your understanding easier. Or when it comes to interpretation of your data, it is easier because it's visual. So when someone uses a pie chart, you're able to understand how your data has been distributed if you're dealing with categorical type of data, okay? If you have a map, you're able to tell regions with most of the sales, regions with, least sales, and so on and so forth. So data visualizations is part of the data analytics life cycle because it makes your interpretation easier, interpretation of data easier, or understanding of your data much easier. Okay. Then we have the insights and decision making. So this is where you interpret analysis into actionable insights. For example, low immunization in remote areas will help you make a decision of deploying mobile vaccination clinics. Okay. Then we have monitoring and evaluation. So this is where you're trying to follow up. What is the progress? So you're trying to track outcomes after implementation. So that is where we have monitoring and evaluation, or M&E. So track outcomes after implementation, and results generate new data for continuous improvement. So that is data. That is the data analysis life cycle. It has about 5 to 8, not 5 to 8, but around, depending on the, depending on the type of analysis that you're doing, mostly it is a 7 steps procedure. Yeah. That is data analytics. Now, we've talked about the data analytics workflow. We now need to proceed to the types of data analytics. And we have 4 types of data analytics. And I'm sure it's going to be easy for you to understand from what I've just mentioned. So not every question requires sophisticated AI. So organizations move progressively from understanding what happened to determining what to do. Okay, so we are coming from understanding the data that we had, or the data that we've collected, to, so what are we supposed to do with this data? Okay, and that is where we are coming from, data to decisions. So we have we have a number of data analytics that you can use. And the first one is descriptive analytics. So we have descriptive analytics, we have diagnostic analytics, we have predictive analytics, and prescriptive analytics. There are 4 of them. Now, the first one is descriptive analytics. And what descriptive analytics does is to summarize historical data. What is historical data? Data that has been collected. So we are using historical data to understand what has already happened. And this is the most common form and the foundation of all other types. Why? Because data has to be collected first before you proceed to analysis. So first of all, we want to understand this historical data to understand what has already happened. So the common techniques when it comes to descriptive analytics are calculating frequencies, totals, averages, and percentages. Okay. We can use, for us to do descriptive analytics, we can use pivot tables and charts, because we are using a pie chart to help us understand the proportion of gender. We had 60% in that meeting. The attendance was, this was the distribution of the attendance. 60% of the attendees were female, then 40% were male. Okay, so we are just trying to understand that data that was collected. That is historical data. So we have an example here. So the Ministry of Health prepares a monthly report. So a monthly report is an example of descriptive analysis. Like you want to understand how many patients were treated in that month, how many children or infants were born in that month, how many maternal deaths did we have, and how many outpatient visits did we have. That is descriptive analytics. What are we trying to do again? We want to understand historical data. We want to understand what has already happened. Okay? So it describes what occurred and not why numbers changed. It's just a description of that data. It's you trying to understand that data. That is the only question. What occurred? That is the question that we are trying to answer. That is descriptive analytics. Okay, I hope that is clear. So we have an example here of county revenue. So we have land rates. So we have revenue source and the amount collected. So from land rates, they were able to collect 450 million. From parking fees, they were able to collect 320 million. From business permits, they were able to collect 280 million. And from market fees, they were able to collect 150 million. So this annual revenue report answers what revenue did the county collect this year. It does not explain why land rates generated more than market fees. Okay? It only tells us what revenue did the county collect that particular year. Okay? Another example that we come across every other day, checking your M-Pesa statement. Total sent, total received, and total spent. So this is basically descriptive analytics. You want to understand the current situation. I hope that is clear. Okay? Now, what is the importance of descriptive analytics? So, it helps in monitoring performance because you're able to track, for example, when it comes to the Ministry of Health, they'll be able to track organizational health in real time. Yeah. Number two, you're able to produce reports. If you are supposed to produce those monthly reports, you usually use descriptive analytics. Thirdly, you're able to track KPIs, key performance indicators. So you measure progress against targets. So this month, we've collected this revenue. At the beginning of the year, these were our targets. Then you're able to compare. Are we headed to our target? Have we reached our target yet? Or what is our current situation? So without descriptive analytics, organizations would struggle to understand current performance. Okay? I hope that is clear. So descriptive analytics, you want to answer the question, what is the current situation? So you're using historical data to understand the current situation. We go to diagnostic. So diagnose. So that is to mean we are trying to find out the reason why. So diagnostic analytics goes one step further. So instead of asking what happened, it asks, why did it happen? So that is to mean, before you proceed to diagnostic analytics, we need to have had descriptive analytics. Okay, the data has to be there. So with diagnostic analytics, we are trying to answer the question, why do we have 250 million as the revenue and from land rates? Okay, so it investigates relationships between variables to identify root causes. So diagnostic analytics is usually used to do root cause analysis. We want to understand, we want to identify why, I mean, why did it happen that way? Okay. So for diagnostic analytics, the common techniques we have is drill down analysis. That is to mean you want to go deeper to get the reasons as to why we have that data as it is. Number two, we have trend and correlation analysis. So with trend analysis, you're able to find out. In January, we had 240 million as our revenue. In February, we had 270. In March, we had 170 million. So what has caused, why do we have that dip? Okay, so with trend analysis, because you're able to observe the trend, you might go ahead and get a reason why we have that trend. Okay, then we have root cause analysis, and you also have variance analysis. Variance analysis is basically what is the difference between last time and this time. What is causing that difference? So that is diagnostic analytics. Again, it investigates why we have, or rather why the situation is as it is. Unlike descriptive is understanding the current situation. Diagnostic, you want to understand why is it that the revenue is at 270 million, yet in February we had 300 million. So we want to find out the reason. We are trying to investigate. That is diagnostic analytics. So we have an example here. In the education sector, there was a KCPE decline. So descriptive analytics, we had the average score dropping from 287 to 264. Okay. Now with diagnostic analytics, after finding out, after investigation, we realized it was because of teacher shortage, absenteeism, poor textbook availability, and floods disrupting learning. So I want you to see the difference. Descriptive analytics is more of figures. Yeah, we want to understand what is the average score. Okay, so there is the figures bit. When it comes to diagnostic analytics, it cannot be figures because we are trying to find out the reason why. So we go deeper to understand those numbers. So our focus goes back to those variables, those factors. Okay, I hope you can see the difference. Yeah. So we have another example here in the health department. So a county hospital notices increased patient waiting times. So investigation reveals, that is diagnostic analytics reveals that one doctor retired. So we have shortage of doctors. Patient numbers rose by 30%. Then only one functioning lab machine. So that is diagnostic. We go ahead and find out, investigate what is causing the descriptive analytics. So diagnostic analytics is not about numbers, it's about understanding those factors. I hope that is clear. So understanding the cause of a problem enables effective interventions. So the wrong cause leads to the wrong solution. Okay. Now, before I proceed, now that diagnostic analytics is more about understanding the factors, that is where we are able to draw insights from. With diagnostic analytics, you're able to draw conclusions. Because, for example, in the second example, investigation reveals one doctor retired. So if this is a conclusion, one doctor retired, so that is to mean we have a shortage of doctors. Then if we have shortage of doctors, how do we solve this problem? So you go ahead and do what? And recommend an action. So if patient numbers rose by 30%, so what could be causing patient numbers arising? Could it be there's an outbreak or something? Then you can go ahead and now talk to the community health department, which is going to investigate whether there is an outbreak or not. If you have only one function in lab machine, so what does that mean? We need to invest in more lab machines. So you can now proceed and maybe raise a requisition to the procurement department for them to give you a lab machine or to get you a lab machine. So with diagnostic analytics, you're able to draw conclusions, and with those conclusions, you go ahead and do what? Make a decision or recommend an action. Okay. Now, the fourth one. So we've talked about, no, it's the third one. We talked about descriptive analytics, diagnostic analytics, then we have predictive analytics. And I'm sure most of you have heard about anything to do with data analysis. We have to predict something or forecast something. So predictive analytics uses historical data, okay, statistical techniques, and machine learning to estimate what is likely to happen in the future. Now, predictive analytics is as simple as understanding the data that you already have, using that data to predict the future. And how do you use that data to predict the future? Or rather, how do you predict future? You predict the future by using statistical techniques. We have different statistical techniques. Yeah, we have regression, and also we have machine learning. Machine learning is part of data science. So we have machine learning algorithms that you can use to help you predict the future. But the most important component is historical data, data that has already been there. Then you apply statistical techniques on that historical data or machine learning algorithms on that data to help you estimate what is likely to happen in the future. It estimates probability, not certainty. So that is to mean it's not going to give you 100%. It's not going to give you 100% prediction. It can give you 87, 80, 75, and so on and so forth. Yeah, so that is predictive analytics. So the common techniques that are used in predictive analytics or forecasting, we have regression analysis, we have time series, sorry. Sorry about that. So you have regression analysis, we have time series forecasting, we have machine learning models, and we have classification and probability models. So in the public sector, the Kenya Meteorological Department analyzes rainfall, temperature, and satellite data to predict heavy rainfall, drought, and flood risks, which help counties prepare in advance. We have the Ministry of Health, which analyzes disease surveillance data to predict malaria outbreak areas during rainy seasons. And this one, with predictive analytics search, it enables pre-distribution of nets and medicines. Then for KRA revenue forecasting, it analyzes 5-year tax collection trends to estimate next year's revenue, which supports national budget planning. So those are the applications of predictive analytics. Just a minute.
Hello, everyone. Hello, everyone. Can you hear me? I hope I'm audible. As Wangari is taking, sorting out an issue on the other side, I think I want to make a few clarifications that we are seeing on the charts. It has gotten to attention that some participants are asking, or they've been requested to pay a certain amount of money to get the link to join on Teams. I want to categorically say that that's false. There is no any amount of money that you need to pay for this session. I think Mr. Coney from ICT, you can retaliate that. We are seeing that on the charts from the YouTube live, and also I think there are some that have come here. I think that one should be very, very clear to anyone. Also, those guys who are on YouTube, you don't have to pay anything to join on the link. The link that was sent through the email that you had registered with, that's the link that you're using. We're also sending a meeting ID on the YouTube page so that you're able to join here. There's also an attendance list. Mr. Coney, if you can also answer this. They're asking for the attendance list. Kindly shed light on that. Those who are on YouTube, they're asking on that as we wait for Ms. Wangari to join us.
Ricky, and for anyone, we know as Kenyans at times we become crappy and we want to
Mr.
make
Coney,
a quid out of everything. Yes, am I audible enough? Audible enough?
Mr. Coney, are you there? Anyone from the ICT team?
Yes, we can hear Mr.
Ricky,
Coney. We can hear you, Mr. Coney.
Okay, thank you. I'm saying that's quite unfortunate for anyone who might have come across anyone trying to scam. As mentioned earlier, these trainings are free of charge. Kindly, if you received the link via email, join. Don't listen to anyone else giving false information. But scammers will always be there. It is us how we react with them. I'm hearing about the attendance link. In all WhatsApp groups, we have filled out the attendance link. I'm also sharing it on the Q&A. And Ricky, I'm also sharing it with you to post on the YouTube for people to be able to fill out the attendance, because unless you fill out this attendance, we won't get that you're able to attend, and we might not share the training materials and even the assessment with you to access the certificate. So ensure in any WhatsApp group that you are, you fill out that attendance form for people, for us to get your details and enable us move forward. I don't want to interject. I know the trainer is back for her to continue with the class. Asante. And to the trainer, before you come back, I don't know. It has been quite a very nice session and we are past halfway mark. Is it possible you give us a small break of around 5 minutes, then we come back as our trainees in the class? What you are kindly grant us that permission.
Yes, I think we can take a break, a 5-minute break, kindly. Then you can be back by 7:14 or 7:15. Yeah.
Okay, let's be back at 15:15.
Okay, 7:15 it is.
Thank you, Wangare. You can still continue sending in your questions for the far that we've gotten, and as we continue looking at them and preparing for the Q&A. Thank you.
So welcome back. We continue from where we left. So we were talking about predictive analytics and where we apply predictive analytics and how we go about predicting. So we've said we use historical data together with, or we apply statistical techniques or machine learning algorithms methods on that historical data, then we are able to predict. And just to repeat, whatever we are predicting is a likelihood, is a probability. So it doesn't have to be 100% accurate. Actually, most times, the kind of accuracy that is, the threshold that is allowed is from 75% to mostly 90%. Yeah, so that is the kind of likelihood. Now, we have predicted. So once we predict, after predicting, we have another type of analytics that is known as prescriptive analytics. So with prescriptive analytics, we are prescribing. So there's a prescription somewhere. So in short, we are recommending an action. So prescriptive analytics goes beyond prediction. It recommends the best course of action. So it combines predictions with business rules, optimizations, and AI, artificial intelligence. Now, we predict to get what is likely to happen. Then we then we have the optimization bit. So what are the best options? Then we go ahead and recommend. So what should we do? Remember, with prediction, we are looking at, or rather we are estimating a likelihood. Yeah, we are estimating a likelihood. Then, as we are estimating the likelihood, we look at what options do we have. So what are the best options? Which options are going to give us the best results or the best estimation? Then from those options, we can now recommend an action. So what should we do? So we can work with option A. Why? Because option A is likely to give us more revenue compared to option B. So that is prescriptive analytics. We have an example. If we have county water shortage, so the prediction, or from the predictive analytics, dry season, it predicts dry season shortages, and then you go ahead and recommend increase water bowsers, drill boreholes, repair infrastructure, and allocate emergency funds. Now, with prescriptive analytics, you're kind of giving us a solution, but this solution is not coming from what you're thinking. It's based on predictive analytics. So you have to do some analysis before you come and prescribe an action, okay? Or recommend an action. So another example, in cases where you have a hospital or rather a disease outbreak, so it's going to predict patient surge. And with that, that is to mean we're going to have increase in patients, right? So we need to recruit temporary staff to ease the traffic. We also need to increase medicine stock. We also need to extend hours and also open treatment centers. In agriculture, you predict using weather and soil data. You recommend an action, suitable crops per region, best planting dates, and fertilizer schedules. So in short, with prescriptive analytics, you're able to recommend an action. You're kind of giving a solution based on predictive analytics. And remember, we said under predictive analytics, you predict Then you look for best options. Then from the best options, you do what? You recommend an action. In the process of recommending an action, remember, you're trying to solve a problem. So you're trying to give a solution. That is prescriptive analytics. I hope that is clear. So the 4 types of analytics, we have descriptive. We are answering the question, what happened? So for example, so you want to understand the current situation. So the monthly county revenue report by source. So what is the current county revenue? And then you go to diagnostic. You want to find out. So you drill down to get the reasons. So why did it happen? Why do we have that data? So in this case, we are investigating why immunization declined in a sub-county. And we've said for diagnostic analytics, it is not numericals now. You want to get those reasons. You want to understand those factors, okay? Then we have predictive analytics, what is likely to happen in the future. So you have to use historical data and apply on that historical data, you apply statistical techniques or machine learning algorithms, then you'll be able to forecast what is likely to happen in the future. So for example, forecasting drought using historical weather data. Then prescriptive analytics, what should we do? What solution are you trying to offer? So this is where you recommend an action. So recommending water rationing during predicted drought. Those are the 4 types of analytics. I want you to realize that we are building up from descriptive analytics. We find out the reason, then we go ahead and predict, then we go ahead and prescribe an action or recommend an action. Okay, so but there are those times that they just need descriptive analytics. They just need you to explain what happened. Yeah, but if you are to go by the the entire data analytics life cycle, then you have to start from descriptive analytics all the way to prescriptive analytics. Those are the 4 types of analytics. Now we have an assessment here. So the Ministry of Health has observed the maternal mortality increased in County X over the past 2 years. So if you were to perform descriptive analytics, you're supposed to answer the question, what data would you summarize to understand the situation? Then under diagnostic, what factors might explain the increase? Then because you're finding out, you're investigating. Then under predictive analytics, what could happen over the next year without intervention? If things didn't change, what would be the likely, what results are we supposed to expect in the coming year? Then under prescriptive, what actions would you recommend to reduce mortality? This is a practical example of what researchers do in the health department. Okay, I hope that is clear when it comes to the 4 types of data analytics. Yeah, please remember those ones, and remember each one of those, they have their own uniqueness in terms of the question that is being answered at every stage. Okay, now data analytics is an ecosystem. To mean it has different disciplines. Yeah, so data analytics is basically an umbrella of a number of disciplines, and the disciplines that we have are the first thing first, data has to be there. Data is the fuel for data analytics ecosystem, for the data analytics ecosystem. So we have to collect data and manage that data. Then we proceed to business intelligence. And business intelligence is basically exploring your data and reporting. So we explore that data to understand and now create reports from that data. Okay, in short, you want to explain in form of reports what is happening. You want to use a pie chart, you want to use a dashboard containing a number of visualizations to explain to us what is happening or what that data has. Okay, then we go to data analytics. So under data analytics is where we analyze patterns, trends, to draw conclusions. Okay, so you can analyze just to get the summary of your data. Like you want to know what was the average score for this particular class, what was the average number of attendees for that particular training, and so on and so forth. So that is data analytics. Then we have data science. Under data science, that is where we predict and adapt. We predict and build models, then we automate those models. Under data science, that is where we have machine learning algorithms. So we don't stop at analyzing, we go ahead and do predictive analytics, and also automate the entire process. Okay. Then we have artificial intelligence. I'm sure right now everyone is aware of what, I mean, at least you know one or two artificial intelligence tools, ChatGPT, Cloudy, we have Gemini, and so on and so forth, yeah? So with artificial intelligence, is basically machines being able to simulate human thoughts or human intelligence. And of course, for artificial intelligence, it is usually built up from data, a lot of data, feeding a system with a lot of data or a lot of information. So that is the data analytics workflow, ecosystem. So I know we've come across business intelligence, and I know some of us here are business intelligence analysts. Yeah. So what is business intelligence as part of data analytics? Business intelligence is collecting, organizing, analyzing, and presenting data through reports and dashboards to support operational and strategic decision making. So with business intelligence, our focus is we have collected this data. We want to organize this data, analyze it, and now present our results through reports and dashboards. And what do these reports and dashboards contain? They contain visualizations. Okay? So business intelligence is basically a representation of analysis in form of visualizations. So we cannot have business intelligence without visualizations. Like we are trying to visualize our results. Okay? And business intelligence focuses on, one, monitoring organizational performance. That is the first thing. Number two, tracking KPIs in real time. You have your KPIs. For example, something like total sales, average scores when it comes to schools. You have total number of patients in a hospital setting, and so on and so forth. So you have, every sector has its own KPIs, key performance indicators, those things that you look at every month, and they'll be able to tell you how your business or your institution is performing. When it comes to schools, you want to look at what was the performance in this particular department. So what was the average score? What was the mean score? Okay. So with business intelligence, you're able to track KPIs in real time. Number three, you're able to create interactive dashboards. Interactive, that is to mean you can add some slicers. For example, if your data has a number of regions and you want to concentrate, or rather focus on one particular region, we have slices that you just select that particular region, and the visualizations that are displayed there, they display information for that particular region. Okay, that is business intelligence. And then lastly, it helps in supporting routine decisions. Routine decisions, for example, we have monthly reports. You know that by 5th of every month, I'm supposed to have submitted a report, a monthly report. Yeah, so with business intelligence, you're able to do that. Yeah, and for you to be able to perform business intelligence or to effect business intelligence, we have the tools that are commonly used. We have Power BI, Microsoft Power BI. Then you have Tableau. We have Looker Studio. We have Click. Then we have SAP Business Objects. But the most commonly used ones are Power BI and Tableau. And the most common one is Power BI. And I believe the simplest one is Power BI. So those are the business intelligence tools. Again, the difference between business intelligence and these other types of these other disciplines under data analysis is that business intelligence focuses on visualizations. Please do not forget that. Business intelligence is basically visualizing your analysis. Okay? And you're visualizing this analysis in form of reports and dashboards. I hope that is clear. Yeah. An example here, so the National Treasury develops a Power BI dashboard showing ministry budgets, expenditure, development versus recurrent spending, and budget absorption rates. So that is a Power BI dashboard. It's showing each ministry and its budget, its expenditure, development versus recurrent spending, and also budget absorption rates. These are some of the things that we'll cover tomorrow under business intelligence. So when do we use business intelligence? In cases where we have daily operations, like you want to monitor real-time performance. I don't know if we have some people who use POS, point of sales systems. In POS, they usually give you a report. Yeah, they usually have dashboards and reports. So if you want to see your daily sales, whether it's in a supermarket or in a restaurant, you're able to, it's visualized. You have those reports, and the reports are in form of visuals. So you're able to tell this was the distribution of these sales of this particular department. We had 50% from maybe department A and 20% from department B. The rest was from department C and D. Yeah. So in cases where you have daily operations and you need to monitor real-time performance, you can go ahead and have a BI tool for that. In cases where you want to track your KPIs, yeah, you want to see what is the current performance against our targets. So this is where you have KPIs like total sales every month, monthly total sales. Maybe your target every month was, at the beginning of the year, was 500,000. And last month's sales were 400,000. You're able to tell, are we headed to our target? Have we reached, or how far are we from our targets? Yeah. Then we have regular reports. You want to automate routine reporting. Again, for those people that are supposed to send reports by 5th of every month, you can go ahead and use a BI tool and you can automate that process. Yeah, that every 5th of every month, you're able to share that report. Yeah. So that is business intelligence. So the difference between data analytics and business intelligence, and in as much as business intelligence is part of data analytics, is that business intelligence monitors current performance, while data analytics investigates why events occurred. Business intelligence answers the questions, how are we performing? That is the question that we're trying to answer. Then with data analytics, what happened and why did it happen? With business intelligence, we have dashboards and standard reports. With data analytics, we do analysis, statistical analysis and interpretation. Then with business intelligence, we use historical data and real-time data. And with data analytics, we identify opportunities for improvement. That is the difference, yeah, between data analytics and business intelligence. Now, we have another discipline by the name data science, and right now it's very common. And data science is a multidisciplinary field which combines statistics, mathematics, programming, machine learning, and domain knowledge to solve complex problems and extract deeper insights. So data science is basically a combination of statistics. So you need to have some knowledge on statistics, mathematics, because formulas have to be involved somewhere. Then you have programming. Why? Because we use a programming language for data science. It could be either R, which is a statistical programming language. Sorry about that. Or Python for, Python for data analysis. Yeah. And then we have machine learning algorithms and domain knowledge. Very important. Domain knowledge. You need to understand what happens in that particular field. Whatever data science project that you're doing, is it in maybe predicting fraud, bank fraud? Then you need to be well versed with that domain. You need to know what factors do they look at. Yeah, when it comes to being approved for a loan, you need to understand the dynamics around credit facilities. How do they work? Yeah, so those are some of the things that you look at when it comes to data science. So data science involves advanced statistics and programming. So again, I've said the most commonly used programming languages are two. We have R, which is a statistical programming language. So you have to code, but the codes are not as, they're not complicated. We also have Python, which are also not complicated, sorry. Then we have machine learning and predictive modeling. Because with data science, we do not stop at analysis. We go ahead and analyze, not analyze, but predict. Then from predicting, we automate the entire process, okay? Then we have big data and artificial intelligence, and also you can use structured data or unstructured data. So that is to mean with data science, there is no limitation of the kind of data that you're using. You can go ahead and do an image recognition prediction type of project. So in that case, you'll be using imagery type of data. You'll be using images. In cases where you want to predict weather, yeah, so you're dealing with numerical type of data. So with data science, you can either use structured data or unstructured data, again, depending on the task that you're performing. So the tools that are used for data science, we have Python, we have R, those are the programming languages. Then you have SQL, we have Jupyter Notebook, we have TensorFlow, and we have Scikit-learn. Scikit-learn and TensorFlow are libraries that are used in Python, yeah? And Jupyter Notebook is an IDE. It's a platform that is used to write, where you write your Python codes, okay? That is data science. Again, where do we apply data science? I'm going to use this healthcare example. So researchers analyze years of hospital records to build predictive models, yeah? So, which help in identifying high-risk individuals for early intervention, going beyond simply reporting current cases. Okay, so that is, you want to predict the likelihood of a patient getting diabetes based on their records, yeah, based on the symptoms rather, yeah. Then with that, you'll be able to, you know, to intervene at an early stage. Yeah, so those are examples. Another example, sorry, KNBS combines census data, satellite imagery, and demographic information to estimate population growth in rapidly expanding urban areas. And after they are done with that, that information will help in supporting long-term planning for hospitals, schools, roads, and housing. So we use data science, or rather use data science when you need to solve complex problems, build predictive models. So you're building these predictive models to be used again and again and again. And that is why we are automating the processes. Analyze large data sets or discover hidden patterns. Okay, so that is data science. Then we have machine learning. Machine learning is part of data science and artificial intelligence, or machine learning is a foundation of artificial intelligence. So machine learning enables computers or machines to learn from historical data and improve performance without being explicitly programmed. So algorithms identify patterns and use them to make predictions on new data. Okay, so with machine learning, we have a set of data. This data is fed to a machine. Then the machine learns, or the computer learns from that historical data with an aim of creating or building a predictive model that will help in identifying patterns or even making new predictions. So common applications, we have fraud detection. If you want to build a fraud detection machine learning, not a fraud detection system, you usually use a machine learning algorithm. Disease prediction, you want to classify what is the likelihood of someone ailing from disease A and not disease B. We use machine learning. Then we have demand forecasting, customer segmentation, then we have image recognition. That one is under machine learning. We might not be able to get deeper into machine learning because it's a wide area. So maybe for someone who is interested, they can just check how you go about machine learning. So an example is tax fraud detection, where machine learning models identify taxpayers whose filing patterns resemble known tax evasion cases, highlighting high-risk cases for investigation rather than auditing everyone. When it comes to agriculture, where can we apply machine learning? In yield prediction, so using weather data, soil conditions. So I want you to realize you're gathering a number of factors. So we have weather data, soil conditions, and harvest records. You're able to predict expected maize yields per county. And with that, it helps officers plan extension services and input distribution. That is machine learning, yeah? Lastly, we have the artificial intelligence or artificial intelligence. And I'm sure we've come across this, we've used this, and we are still using this. And artificial intelligence simulates human intelligence, enabling systems to reason, learn, solve problems, and understand language and make decisions. So AI builds on machine learning and includes natural language processing. Like when you're using ChatGPT, you use natural language, yeah? So we have that, we have computer vision, where in cases where you have imagery type of data, then you have robotics and generative AI. So unlike traditional software, AI systems adapt, they learn from new information and continuously improve. So they keep on learning, and as they keep on learning, they keep on improving. So you, the information that you're likely to get today compared to yesterday's is more accurate. Again, depending on the kind of data that has been fed on it. So common applications, we have virtual assistants and chatbots. We have document summarization. I'm sure you've been using this. Speech and facial recognition. Then we have language translation and intelligent automation. Common AI tools, we have ChatGPT, Microsoft Copilot, we have Google Gemini, we have Cloudy, we have Azure AI, we have TensorFlow is a library that is used in these AI tools. Yeah, and we have many others. We have 11 labs for speech and so on and so forth. So that is under artificial intelligence. So where do we use AI when it comes to public sector? AI assists radiologists by identifying potential abnormalities in X-rays and CT scan images, helping clinicians prioritize urgent cases. When it comes to disaster management, AI analyzes satellite imagery, rainfall data, and river levels to support early warning systems for floods and landslides. And in cases of maybe in a Huduma Center, AI chatbot answers citizen questions on passport application, business registration, and driving license renewal, reducing waiting times. Okay, this one is not yet in Kenya, but maybe for those that are in Huduma Center, maybe this is something that you can think about. But the Huduma Centers that I've visited, I have not come across this. Yeah, but those are some of the applications of artificial intelligence. Yeah, so this is the comparison between the 5 disciplines, and I think because of time, I'm not going to go through that. It's already 7:47. The session is supposed to end at 8, and we have some questions that we're supposed to cover, or rather to tackle. So we're going to continue from data collection, cleaning, and preparation tomorrow. For the remaining 12 minutes, allow me to answer the questions that I can be able to answer. Then the other questions, we're going to give you the answers. Again, there's a link that has been shared where you can write down your questions. Then we're going to answer them from there, and you're going to get that document. So I think I'm done with today's session. So allow me to proceed to questions. Ricky, Malcolm, are you there?
Yes, we are here. Malcolm is compiling a few questions, and then we'll be able to go in a few. Thank you so much, Wangari.
Thank you very much, Wangari. I think first and foremost, over and above the questions I've received, there's a lot of applause regarding the content and training material. Looks like the learners are actually ingesting a lot of knowledge, and your expertise in data analysis, it's quite overwhelming. So we have a lot of questions, I believe around 50 to 60 questions. And since we probably have like around 10 minutes, I've been able to pick the ones which are seemingly a bit more prevalent than the rest to just highlight to you instead of just sharing them. So I can maybe just throw a question and you can just answer, and then I can go to the next. But that should work.
Yes. That's okay.
Amazing, amazing. So we have one here from an anonymous user. So he's asking, what is the most appropriate and ethical thing to do once you have missing or inconsistent data dealing with personal information where the respondent cannot be reached for clarification? Let me just repeat that. What is the most appropriate and ethical thing to do once you have missing or inconsistent data dealing with personal information where the respondent cannot be reached for clarification?
That's a good one. I think these are my thoughts because that's a unique question. The most appropriate way of dealing with personal data, because you cannot add information. This is not numerical data. And even if it was maybe something like age, you don't know their age, so you cannot guess their, year of birth. So in some cases, you just have to leave. You might have to do away with that row of that particular person. Okay, because you cannot, this is personal information, you're not able to reach this person. So, and again, if we're assuming you're collecting data about, you see, when you want to apply for a passport, they ask for your details. Do you have any special, any special, what is it called? Maybe you have blue eyes or something. You might not be able to guess that. Yeah. So there are those cases. You might just decide to do away with that particular row. In cases where it is compulsory for you to have details about that person, you might just work with amongst the 5 people that I have, what is the mode? Majority of these people, what characteristic do they have? Then you can work with that. But you see, something like gender, you might not be able to guess. Yeah. So the thing is, for personal information, I would advise you do away with that particular row. Yeah, but if it's something that you can guess, or not guessing per se, if it's something that you can use another person's, or you can do an average of these other people, then you can do that. For example, if you're working with age, we are looking at, we missed the age entry or the age record, you can decide to do the median of that particular column. If you have a number of people, then you just use that particular number. Yeah. But when it comes to specifics, you might just need to do away with that particular row. Yeah.
Amazing. That is extremely detailed. I hope user anonymous 0011, you've gotten that. Thank you for that question. And then I think the one that has actually gotten most of the notation is duplication of data. We had mentioned data duplication. We have to do this when we are actually cleaning data, but people seem to have an opinion that sometimes if you run a duplicate check on a set of data, maybe you might miss out on some information. So I can just highlight one that clearly stood out here. The question: is it always advisable to remove duplicates in, let's say, for example, sales data? They're actually just quoting, what if a client is a regular and has been buying the exact same thing like coffee several times? Wouldn't removing these duplicates, which are actually individual sales record, affect the total revenue generated when doing your analysis? So you can just break down the importance of data, removing duplicates in a data set.
Okay, now good question there. Now, duplicates are a repetition of a particular row. So we have row 1, details of row 1. Say we have transaction ID 001. Then you go to name, Wangari Muchai. Then you go to age, say 21. Then we go to say subject, we have statistics. Then detail, I mean not detail, but the second record is 001, name Wangari Muchai, age 21, and subject statistics. So you realize all the details, all the columns are similar. Whatever, I mean, if it's 001 in record 1, it's 001 in record 2. So that is a duplicate. Now, for the question that have been asked, in cases where you have a regular customer, something has to identify, or there has to be something that is distinct between they came yesterday and they came today. In as much as they are buying the same thing all those times, or the 2 times they've come to that shop, they visited the shop, you're going to realize either the transaction ID is different, or maybe the order ID number is different. Okay, so there is that difference. There is a difference between a duplicate is where all the records are similar. They are the same, not similar, they are the same. But in cases where this person is a regular customer, there is something that is going to be different, and most likely the transaction ID is going to be different. So day 1, it's going to be T001. In day 2, it's going to be T002. Then the other records or the other details are going to be the same. Yeah, but we have something that is different. So in cases where the records are the same, they have been repeated, that is redundancy. Okay, redundancy. And redundancy, of course, that is to mean we are repeating this information, and there is no need of repeating this information because, I mean, it's the same information, so you have to remove that one record. And the solution to duplicates, again, the solution is not replacing, it is removing them completely. Whether you're using Excel, Python, or something else, you have to remove them. Okay, that is the solution to duplicates. But for the example that has been read out, trust you me, something must be, there has to be something that is distinct between the 2 transactions. Most likely the transaction ID, if you're talking about sales, the transaction ID is going to be different. Yeah. I hope that is clear.
That is very, very crystal, Wangari. And I think in the interest of time, I'll just throw you one final one as we wrap up. And this one is one I think you might have fun answering it. How do we validate that our data-driven recommendations are actually accurate before presenting them to decision makers?
Come again?
Let me just repeat that. How do we validate, we as the data holders, that our data-driven recommendations, and I'm guessing this is someone who is probably doing a report in some organization, that the data-driven recommendations are actually accurate before presenting them to decision makers?
Okay, good question. So I'm going to take you back to the 4 types of analytics. And even before then, I'm going to take you back to the data analysis life cycle. We said, first thing first, you need to understand the business problem. Once you understand those business questions, you'll be able to know already at the back of your mind, you know the kind of problem that I'm dealing with. Yeah. So once you understand that business problem, we now go to the types of analytics rather. We have, the first one is descriptive. You want to understand, this is the data that I have. Number 2, you go to diagnostic, where you try and identify or investigate the reason behind this particular happening, why we have this data. Okay. Then after that, we can now proceed to what? Predictive analytics. Then we go to prescriptive, where we recommend actions. Now, remember we said once you understand the reason why, once you go identifying the root cause, what caused this particular data to be this way? What is causing these changes in our trends? Yeah, you will be able to now know the action to recommend. Yeah, because you already have evidence. I already have evidence that factor 1 and factor 2 contributed to the happening of this data. Therefore, if this is being caused by factor 1 and factor 2, then this is what I recommend. So my answer would be by making sure that the diagnostic analysis is well done. You know, it is well done, like you understand kabisa what caused this particular issue, what caused this particular change. You do your root cause analysis the way it's supposed to be done. If your root cause analysis is accurate, trust you me, the action that you're going to recommend is going to be accurate as well. Yeah.
Thank you very much, Wangari. That is very, very well explained, and I think it just goes to the cycles you had actually mentioned, and the application that people can be able to just adapt to them when you're dealing with various sets of data. We'd love to get you to answer all these other questions, but unfortunately, we've actually clocked our time. I think for the students who are online, we've been able to address some of the questions, and we will continue to do so tomorrow as well as the following day. But for now, thank you very much, Ms. Wangari, for the insightful lesson 1. We hope to see you again in the course of the program. I think I can probably hand it over now to Ricky for a comment or so. Back to you, Ricky.
Thank you. Thank you, Wangari. Thank you, Malcolm, for that session. I think from our side, we're just grateful. As Malcolm has stated, this is just day 1. And so as we come to the end of our first day, we just want to extend our appreciation to our facilitator, Ms. Wangari, for engaging and for these engaging and insightful sessions. Thank you for sharing your expertise and laying a strong foundation in data analytics. To the participants, thank you for your active participation, thoughtful questions, and we are looking forward to seeing you tomorrow. So your commitment is really key going forward, and we definitely will have a very good interactive session tomorrow, we believe so. Without much further ado, Mr. Coney from ICT, please, you can take charge and then give us direction. Thank you so much.
Ricky, and let me first start by recognizing our trainer for the day, Wangari. So much knowledgeable on this field. We deeply appreciate. I followed the class all through. Because it's already late, tomorrow let's meet same place, same time. We'll be using the same links, and please ensure that you join the WhatsApp group and you're able to fill the attendance form, because at the end of the day, we'll need to share the materials with you. We need to onboard you for an assessment, and that's where we now need the attendance form. Thank you so much. See you tomorrow. Don't fail. I know the class will be more interesting than today. Asante, bye bye na usiku mwema.